This video will introduce you to how the Bluetooth Low Energy Protocol works and how it can be implemented on an ESP32 microcontroller. So let me explain you how basically this protocol works. So I go to the whiteboard and imagine this is the ESP32 microcontroller as we have it over here. And let me say ESP. Okay, now the Bluetooth Low Energy is basically based on services, and the services define the way the microcontroller sends the data, how it receives the data, what it should send out, and so on. The simplest service that it's available in the Bluetooth Low Energy protocol is the GAP, which basically represents generic access profile. This is basically working like a beacon. So basically the ESP32 will send out data to the other devices and will notify them about a certain event. This is how basically the iBeacons work from Apple. They are basically small devices placed inside stores, and they send data to the customers regarding sales and offers and so on. Now, let me tell you how. Now let me tell you all the attributes in GAP device. So a GAP device will have basically a data which will be sent every, let's say, 100 milliseconds, but this interval can be changed. So this is the data, and let me show you how it will send. So this is the diagram. The peripheral is the ESP32 microcontroller. It will basically send the advertising data to the central peripheral, central device, which is basically, it could be any Android app, any computer that has Bluetooth functionality. Then whenever the central device receives the data from the peripheral, it will scan response. It will basically request a response. This means that it says, okay, I've seen you, now I need to get the data from you. And basically the peripheral, which in our case is the ESP32, will send back the data, which is the same data, as I said, which can be a link, a string, and so on. And after it sent the data, it goes into the advertising state again. Advertising basically means sending out data to the other devices. Now, let me tell you all the other characteristics that this ESP32 microcontroller must have. It must have an appearance. An appearance is basically identifying the type of the device. It would say, this is the generic device, this is a plane, an automotive, a mobile phone, and so on. So I'll say over here app in short. Then it should have a device name, obviously, because as you've seen on your phone, it's basically the string that appears in the Bluetooth tab. So we have here a device, actually name, I should have written here. Yep, I should, yeah, name. And that's basically it. Let me show you the code. On VS Code, I've already written it, but I will explain it step by step. It will be using the NVS flash because it's storing the received data inside the non-volatile storage flash memory. Then we initialize the Nimble, which is basically the library that we will be using in this series. It is basically an adapted library only for Bluetooth Low Energy. Then we initialize the GAP service. Let me go to its definition. Wait, why can't I? Yeah. And basically we initialize the GAP functionality. Then we set the device name, in our case ESP32BLE. I've chosen a random name. And then we say generic tag, meaning that it is a generic device. It's not like a plane or something like that. And that's it. That's what the GAP init function does. Then we have to go again to the main function to show you the next functions. Then we have nimble host init. This basically takes care of the callbacks. As you can see over here, it takes care of this reset callback. It will say here, if I go to the reset function, it will say here nimble stack reset, the reason, reason. And then we have the stack sync. I forgot to tell you what is synchronization based, basically. So we have the controller, the Bluetooth controller, which is basically the hardware, and then we have the host side, which is basically the software that controls the Bluetooth controller. So the synchronization happens when the Bluetooth controller can send and receive data, and basically the host has access to that controller. That's when the synchronization starts. And then once the synchronization starts, we can start advertising. And this basically stores the received data inside the flash. That's basically it about the host initialization. After we have synchronized the host controller and the software side, basically we have to initialize the advertising. I've already explained you how it works. If you go to the advertising function, by the way, if you're interested in learning more about embedded systems, I have a free school community about microcontrollers in which you can get more access to me. I am hosting also weekly webinars on various topics within embedded and so on. Enough with this rambling, I'll go back to VS Code. So we initialize here the advertising. This function, BLE agency ensure address, basically takes care of whether we have assigned a unique address to the microcontroller or not. And basically, if it finds that no address is assigned, it will say this error. Then this function will set an address on the microcontroller if none is found. And yeah, it's a random one because I passed 0 over here. And here, BLE ages ID copy address will basically copy the address so we could print it on the terminal. So it is not mandatory to do this. Then we start advertising. Let me show the function of advertising. So it's up above here, and here we basically set the name for advertising, then the power level, then the appearance, then the role, which is 0. In this case, it will be a peripheral, and basically this is assigning the fields that we've set, and then this is the so basically these are the settings for the advertisement, and here we have the setting for the response that once we receive a response request from the central peripheral, we will basically send this payload. So we're basically setting the address value, the device address. We have retrieved it in the previous function, and here we're setting the response set fields. And here we start the advertisement. So, but that's basically it. Let me show you how you basically send custom data. So if you go here, not actually, yeah, here to RSP fields, if I say RSP fields dot MFG, is basically the manufacturer data, and I could say here, I don't know, hello world. I don't have any other idea that could be better in this case. And there's actually a catch here, because the payload that is sent in gap must follow an order, and the first 2 bytes are actually 2 bytes for the manufacturer data, and they'll be truncated. So I'll say here 0, 0 like this, and actually I have to typecast it to unit because otherwise I run into errors. And now I have to set the length of the fields dot mfg data length, which is no, actually 13 in our case. Let me flash the board. I'm using an ESP32C6, so I will connect the board and I'll flash it. Okay, it's flashed. I will connect my phone. So as you can see over here, it says advertising started. Now I will open the NRF app. You'll find the link in the description, and I'll open enable the Bluetooth, and I'll set the scanning mode. Let me see if I see the ESP32. No, I don't. I'll press scan again. As you can see, I get the ESP32. If I click on it, you can see over here the sent data, which is in UTF-8 encoding scheme, the hello world. So that's basically how the generic access profile works.